This week in GESM 160, we will focus on learning from lectures and textbooks. This lecture will be the first of 3 to discuss metacognitive strategies. Before we jump into the metacognitive strategies that will make us more effective readers and note makers, let's review metacognition. Metacognition is the awareness and control of one's thinking, meaning there is both a knowledge and a control component. The knowledge component refers to what a learner knows about cognition, including the knowledge about themselves as a learner, about aspects of the task at hand, and about strategies needed to carry out the task effectively. The control component refers to the strategies a learner uses to make cognitive progress, such as planning how to approach a task, evaluating progress as the task is being completed, and changing tactics if difficulties arise. Metacognition is a higher level of cognition. It is cognition about cognition, or thinking about thinking, or reflection. It is knowledge about cognition and control of cognition. Metacognition also enhances a learner's self-regulation. If a learner is able to reflect on their learning strategies, they can determine which strategies were the most or least helpful and plan to change strategies in future study or practice sessions. This type of reflection, or thinking about one's thinking, has been shown to impact learning in all domains, meaning metacognition is useful in all learning situations, whether a learner is prepping for an exam, writing an essay, solving a calculus problem, composing music, honing a new skill in the pool, or learning new skills for their job. Metacognition enhances learning in all domains. Metacognition is the knowledge of the skills and strategies to use on a particular task. It is strategic thinking about how to improve learning and performance by knowing the most effective approach to take when executing a task. It is also knowing how and when to use these skills and strategies to successfully complete a task. But most importantly, metacognition can be learned. This is a critical fact because it means that this is a skill that can be taught, learned, and mastered. Metacognition is a vital part of being a successful learner, but it is not an elusive skill that only experts have. It can be developed and practiced by anyone, and most educational psychologists believe it should be taught from a young age. This fact is the basis of this lecture. We can improve our practices as readers and note makers by improving our efforts in developing metacognitive strategies. Let's start a discussion about which strategies we can use when we're note making in lecture. How many words do you think are in an average lecture? It's actually about 5,000. This is a lot of information that we have to process. So when we're thinking about strategies to use in a lecture, we also have to consider the information processing system and make a distinction between hearing and listening. In the information processing model, where would you place hearing? Where would you place listening? There's a big difference between hearing and listening. Hearing is a very passive process. It is non-selective and involuntary. When we are hearing a lecture, only our short-term sensory store is activated. Things are basically going in one ear and out the other. When hearing, there is usually something else being processed in our working memory. For example, you may be preoccupied with what you're going to do after class, what happened on your favorite TV show, or a conversation you recently had. But when we are listening, we're engaging in an active, voluntary process. Now, information is not only flashing through our short-term sensory store, but it is being processed in our working memory, the center of our consciousness. It is here that we are deciding which information is key. We cannot take down verbatim notes, and even if we could, it wouldn't be effective to. So we have to decide which of the 5,000 words that we're hearing are we actually going to write down. Now this is an important point if you're taking notes, but what if you're sitting in lecture and telling yourself, I understand this, I don't need to take notes? Well, here are some statistics that may change your mind. Here is an image of the retention curve. It illustrates how much information we remember over time from a lecture. So while it is true that we may understand everything that is being said in class, this is not the same as being able to recall and explain this information at a later time. Looking at this graph, we can see that merely an hour after we hear new information, we forget about 50% of it. In 2 days, we retain only 30%, and in a month, about 20% of the information. Let's test this out. Without looking back at your notes from previous weeks, can you recall which of the 7 sins of memory this graph illustrates? If you can recall the name, would you be able to explain the connection between this graph and this sin of memory? Several weeks ago, we learned that transience is the weakening or loss of memory over time. Just as we most likely cannot remember what we ate for dinner 30 days ago, information presented in a lecture fades over time, which is why it is so important for us to write it down in an effective manner. This is especially true in college, when we have to take midterms and finals that can be months away from the time that we heard a lecture. When considering effective note-taking strategies, we must discuss note-making. When we are note-making, we want to be strategic in their format so our notes are useful and effective when we are studying for quizzes, exams, or projects. First, leaving a 3-inch margin will allow for further note-making after the lecture. We'll touch on this in the next slide. We also want to use an indenting format where the main points are closer to the margin and the supporting details and examples are indented. Skipping 2 lines between topics will help us see when there is a change in topic. If you ever have a professor who often jumps topics or goes back to a topic you were previously discussing, it may be useful to skip more lines than 2, so after the lecture you can group like concepts and ideas together that may have been presented separately. Why is taking notes in an organized fashion so important? Thinking again about the information processing system and the small capacity and duration of our working memory, we want to organize our notes as best we can because this will help us to better store and retrieve the new information. What if we have a professor who doesn't present in an organized fashion? In this case, take the notes down as best you can and reorganize after the lecture is completed. Don't ever try to organize during the lecture, as this will definitely result in cognitive overload. It was previously stated that an average lecture has about 5,000 words. We cannot take verbatim notes. In fact, in an average lecture, we usually only write down about 500 words. So we want to be sure that the words we're choosing to record are the main ideas and supporting details. And oftentimes, professors will give us signals. So what are they? When professors repeat a point more than once, write information down on the board, give definitions and lists for concepts being discussed, they are trying to highlight what is important for you to know. Some may even move away from the podium and come closer to students, or alter their voice, speaking louder or slower. And again, although these main points might make sense at the moment, unless you write them down in detail, you will forget them. So we've taken organized notes. We're done until the test, right? Not exactly. When maximizing our working memory, we want to take a few steps after the lecture while the information is still fresh in our mind, including noting which points the professor was really trying to emphasize. It is after the lecture where note-making can be taken to the next level by creating mirror and summary questions. Mirror questions are lower-level questions that can be added to your notes in an unlimited amount. When writing mirror questions, ask yourself, if the information in my notes was an answer to a question, what would the question be? Mirror questions should go in the margin next to the answer, and the answer to the question should be underlined. Summary questions are higher-level questions, and there are usually 1 to 2 per major topic. When creating summary questions, ask yourself, what is one major question that reflects the purpose of today's lecture? Summary questions should go at the end of the notes. You can see here that these questions will become very useful when studying. You will already have a practice test created by taking an extra 10 minutes after class when things are still fresh in your working memory to create these mirror and summary questions. But why do we use questions rather than just keywords or underlining important pieces of information to memorize? Because questions can help us focus on specific aspects of the material. Questions give our brain a goal-directed activity, resulting in a different level of motivation. It results in a more active engagement. All right, so the time has come to review your notes for your final exam. Which one of these notes would be more helpful, the one on the left or the one on the right? Which will help you elaborate and encode the information? Which will help you retrieve the information more successfully and at a faster rate? The notes on the right have been formatted with their purpose in mind, or in other words, the notes on the right were formatted to be effective tools for studying. When we are using metacognition to enhance our learning, we need to be strategic about the effort and time we put into our learning. Taking notes that are formatted for the purpose of studying are a great way to work smarter instead of harder. It was mentioned earlier that mirror questions are lower-level questions and summary questions are higher-level questions. The level that is being referred to is the level of cognitive processing it takes to answer that type of question. Higher-level questions require a greater level of cognitive processing than lower-level questions, meaning they are more difficult to answer. Answering lower-level questions results in rote learning, while answering higher-level questions results in more meaningful learning. We are next going to look at Bloom's taxonomy to better understand the different levels of cognitive processing we engage in when answering these two types of questions. In Bloom's taxonomy, there are 6 levels of cognitive processing. They are remember, understand, apply, analyze, evaluate, and create. Which processes do you think are lower level, and which do you think are higher? The first 2 levels, remember and understand, are the lower level of Bloom's taxonomy. Lower level questions seek for you to recall or explain terms or concepts. Higher level questions require you to apply, analyze, evaluate, or create. This means that you will need to apply the concepts learned, analyze the relationship between 2 or more concepts, evaluate or make judgments based on your understanding of the concepts, and create new products based on your learning. But why is it so important for you to create both higher and lower level questions? The different levels of questions require different levels of cognitive activity and processing, and in college, you are expected to function at the higher level of thinking. Now, in order to understand the higher levels, you must have a strong command of the levels that come below them. For example, you will not be able to apply concepts if you cannot recall or understand the terms. It is also important to understand that while you mainly receive information at the lower levels in lectures and in your textbooks, your exams will have questions at the higher levels. This is why it is imperative to create both higher and lower level questions when studying. Let's look at the following slides for guidance in how to use Bloom's taxonomy to help us study. Here are some active verbs to help you create higher and lower level questions. Let's use these active verbs to create a taxonomy about the iPhone. Imagine that you are preparing for an exam on your iPhone. Here are some of the activities you may engage in to prepare. First, recall your password to open your phone. Explain how using Wi-Fi can save money on your data plan. Demonstrate call waiting without hanging up on the first caller. Compare and contrast apps that you are thinking about purchasing. Critique an app that you already purchased and decide whether or not it was worth the money. Explain this evaluation to a friend who is considering buying the app. Lastly, design your own app that will appeal to the masses. Think about the difference in mental activity that is needed between recalling your password and designing an original app. This difference can often explain why students who worked hard to study for an exam are often unprepared. They only practiced at the lower levels of cognitive processing, while the exam is asking questions at the higher levels. Let's take one more look at Bloom's taxonomy and how it can be used to create higher and lower level questions about the information processing system. As we're going through these questions, reflect on how much cognitive processing or thinking you would have to do before you could answer these questions on an exam. How much more information would you need to be able to retrieve from your long-term memory in order to successfully answer these questions? How long does information stay in the short-term sensory store? Why is it important to encode information we want to remember? Demonstrate the use of mnemonics. How are elaboration and organization similar and different? With the knowledge you now have of the information processing system, assess whether or not students should be allowed to use their cell phones while studying. Why or why not? How would you design a study routine that effectively maximizes working memory? The level of detail needed to answer the create question is much greater than the remember question. Oftentimes, when students are studying, they quiz themselves using only the remember and understand levels. These lower-level questions result in only rote learning. On the other hand, asking higher-level questions results in more meaningful learning, which is conducive to storage and retrieval. From learning about the information processing system, we know these are important functions when needing to demonstrate our learning on an exam. Speaking of IPS, let's revisit it again. When we're reading our textbooks, reading comprehension is the name of the game. Unfortunately, the information in the textbooks and articles we read for class is much more dense than material we read for enjoyment. When focusing on comprehending new information, our information processing system can run into trouble. When material is especially unfamiliar or dense, our short-term sensory store has to work overtime, and some of the signals or words coming in are going to memory loss before we can even have a chance to pay attention to them. Remember, information only stays in the short-term sensory store for a half a second to 3 seconds. When we try to read several pages or chapters in one sitting, we can easily get overwhelmed by the sheer volume of information and basically shut down our working memory and only keep our short-term sensory store activated. In this case, the working memory has become overloaded and crashed. All too many students plow through the pages and feel that they've read it. Their eyes have seen the words, but their minds are a million miles away. This is why it is important to pause frequently and do a check about whether you understood what you just read. What other strategies can we use to be more effective readers? Like taking notes, we want to focus on meaningful learning strategies. But with reading, we want to be sure we are also regulating or controlling our environment. If you are trying to study in bed, for example, this is probably not the wisest choice. Our brains work by association, and our beds are more strongly associated with activities like sleeping. We want to be sure our working memory is active, not getting ready to take a nap. When we're reading, we can often get fatigued even when we have avoided reading in bed. In this case, change positions, stand up. Also, keep in mind that our brains can only take in new information for about 21 minutes. After this, our memory systems start to shut down. So you may need to take a brief 2 to 3 minute break every 20 minutes or so if you are studying new, dense information. Along with studying in bed, college students are often very focused on rote learning strategies such as highlighting and underlining textbooks. The problem is that many times textbooks can end up looking like this. If this is what a textbook looks like when you're trying to come back to the chapter to study for the exam, there's going to be a problem. This type of highlighting not only caused working memory overload when it was being created, but will also cause it again when you are trying to study. The sheer volume of information being highlighted here is overwhelming, and then on top of it, there is some elaborate color coding that also has to stay in working memory. Using this highlighting to review for an exam would result in having to reread almost the entire section or chapter. So highlighting should be avoided since it usually results in cognitive overload. But if you must highlight, here are some guidelines to follow. Read first, then highlight. It can be difficult to determine what the main point of a paragraph or section is until you have read it in its entirety. Highlighting as you go will result in highlighting too much and it becomes useless. You'll essentially have to reread the text again. Have a purpose for highlighting. This purpose can come from the question you created out of the heading or from something more general like creating higher and lower level questions. Do not highlight complete sentences. When you go back at a later time to study, the whole text will not be underlined. You will spare your working memory some needed space by eliminating unnecessary pieces of information. Highlight no more than a fourth to a third of a page. If you have more than this highlighted, chances are very high that you are highlighting too much information. Reread what you've highlighted to ensure that it makes sense. If it doesn't make sense to you right after you've highlighted, it definitely will not make sense to you a month later when you're studying for your big exam. Check to see that you've highlighted all of the important parts and omitted the unimportant ones. A good technique to use as you are refining your highlighting skills is to start out using a yellow highlighter. After you are finished reading and highlighting and are reviewing to make sure your highlighting makes sense, use a darker color such as pink to emphasize the most important information from your original highlighting. So what do we do when we don't comprehend what we're reading? We want to be sure that we're focusing on meaningful learning strategies and that we're being an active reader. Before you even look at the text and as you scan it and read it, ask the questions: what am I going to learn here? What is the author's conclusion? How does the author present the topic? What are the key points to the argument? These questions, which should be tailored to the type of reading that you're doing and the reason for which you're doing it, function to engage you in the activity. For example, if you ask a question in the lecture, you always remember the answer to that question. Similarly, if you become an active reader, you are much more likely to retain the information that you amass. You can also start with the end. Review the major concepts and terms before focusing on the details in the chapter. Use the study aids in the book. These will help to highlight the main points the author is trying to get across. Reread or read on. Reread to make sure that your working memory is active and the words are not just going through your short-term sensory store. Read on to see if the text will answer the question or reveal new information that will help you comprehend the information you're struggling with. Locate another reliable source, such as another textbook or even a reliable website. This is especially helpful if the book that you're supposed to be reading isn't presented well, or if you need the content to be worded a bit differently. Read aloud. Move your lips, make some noise. Why does this work? Primarily because we cannot speak as quickly as we can read. On average, we speak about 140 words a minute, but we're able to read 200 to 250. So it literally forces us to slow down. It will also engage both our visual and auditory channels in our working memory, and will help to focus our entire working memory on the content that we're reading. Focus on comprehension. If you're having a difficult time comprehending the material, give 100% of your working memory's attention over to comprehending. This means stop highlighting or taking notes and eliminate any other distractions in the area. Take the time to read the material without dividing the attention of your working memory. Lastly, it is very helpful to create a representation to visually organize the information. In the next slide, we're going to go over 4 types of representations that can be very helpful in organizing information at the college level. The 4 representations are hierarchies, matrices, sequences, and diagrams. Hierarchies organize ideas into levels and groups. Keywords that may prompt you to use a hierarchy are kinds of, composed of, classified as, or parts of. Matrices can be developed from a hierarchy or a sequence. They display comparative relations. Keywords that may signal the appropriate use of a matrix are like, in contrast, in comparison, or on the other hand. Sequences are used to order ideas chronologically. When a text is outlining steps, events, stages, or phases, a sequence would be helpful. Lastly, diagrams show the appearance and location or parts of something. For example, If you're taking an anatomy class, it will be entirely more productive to have a labeled picture of different muscle groups than to describe the location of these groups in words. When pulling information out of your text to organize it, representations have an advantage over creating outlines. First, similar information is localized. This allows you to see more information on the same page, but at the same time, clutter is reduced. There will be less repetition and unnecessary words. These first two advantages help to dramatically reduce cognitive load and keep the working memory focused on important details instead of being overloaded by insignificant details. On the other hand, when important details are missing, the empty matrix or hierarchy cells would make it immediately apparent what information would need to be found and inserted. Lastly, having all the information in one place helps us to develop the big picture. While it is important to understand key terms and concepts, developing the big picture allows us to apply the concepts we are learning, understand the relationships between them, as well as other higher-level cognitive processes. The following slides provide examples of each type of representation. Here is a diagram of the parts of the brain that enable us to read. As you can see, it is much easier to learn from an image of these parts than to try to describe their locations using words. This example of a sequence shows how several decades worth of information can be put onto one page. Sequences are also great to use for documenting stages, phases, or other types of processes. Hierarchies are great for displaying relationships of groups, as displayed here. A hierarchy displays relationships from top to bottom, but it can be turned into a matrix which displays relationships from top to bottom and side to side. Matrices are great for comparing and contrasting. All hierarchies and sequences can be extended downward to form a matrix. Matrices have three parts: topics, repeatable categories, and details. Topics appear across the top of the matrix. They are the superordinate or subordinate ideas in a hierarchy, or the steps in a sequence. The repeatable categories appear down the left margin. They are the characteristics by which the topics are compared and are what differentiate a matrix from a hierarchy or sequence. They are called repeatable categories because each category is repeated for each topic and allows for comparison across topics. While matrices may seem unfamiliar, we often see them in our daily lives all of the time. Here is an example of a matrix that compares different models of Apple computers. In fact, there's a similar matrix used on the Apple website. Many other retail sites use matrices to help consumers compare their products. A matrix is much more practical for comparing multiple complex ideas or items. It's a fantastic way to engage in meaningful learning. Finally, as you were learning this week, reflect on these questions. Are you aware of and controlling your thoughts while listening to a lecture? Are you note-making? Are your notes conducive to studying? Which strategies do you use when reading a difficult text or article? When studying, do you create both higher and lower level questions? How could you implement the use of representations in your study routine? Don't forget to take Quiz 9 via Blackboard.